Hello guys, so today our topic of discussion is Wavy Curve Method. Now this topic is very important for the JEE examinations, and quite a few questions can be solved using this method. So you have to understand this method very well so that you can apply it in your questions and all. So let's start this method here. See, this method is used for solving inequalities of the type fx is equal to, which I have written here, greater than 0 or lesser than 0, or greater than equal to 0 or lesser than equal to 0, and these are the conditions which are required for so that I can apply this method here. m1, m2, mk, n1, n2 till np all have to be natural numbers. A1, A2 till AK, B1, B2 till BP all have to be real numbers such that none of the A's is equal to none of the B's. That is what I have written in the last line mathematically. So I hope you have got the conditions. Now this method we will learn only through problems. Okay, so let's start our first problem. So our first question is solve for fx is equal to, a function is given. If it is greater than or equals to 0, then we have to find the intervals of x. So now let's see if the conditions hold. The powers of all the factors, they are integral powers. In fact, I'm sorry, they are all natural numbers, all 1. And now none of the a's are equal to none of the b's. And they are all real numbers. So the conditions hold. So now let's see what the Wavy Curve method uses. So just see what we do. We have taken a number line and now we plot all the zeros of the numerator as well as of the denominator. Now see where at which points will the numerator become 0? 1, 2 and 3. So we have plotted those 3 points, and the denominator will become 0 at -1, -2, -3. So we have plotted those 3 points as well. Now the points where the numerator will become 0, we have encircled them with black dots because those are also zeros of the function. And the points of the denominator become 0, we have encircled them with big circles because at those points the function is discontinuous. Okay. So now we have to draw a wavy curve through all these plotted points. Okay. So draw it. And we have plotted it. Now start from here, write plus, and then wherever the curve is above the number line, write plus, wherever it is below, write minus. Plus, minus, plus, minus, plus, minus, and here again plus. So now this inequality is given greater than or equals to 0. Now since it is greater than 0, now just ignore the equals. Since it's greater than 0, we will take only those places where we have written plus sign. So where we have written plus sign, let's see, before -3, between -2 and -1, between 1 and 2, and after 3. So now fx, if we write greater than 0, it implies x belongs to -infinity to -3, union -2 to -1, union 1 to 2, union 3 to infinity. But since it's given equals to 0, so we will have to find where the function can attain the 0 value, and that we know it will be at the zeros of the function, which is the zeros of the numerator. So 1, 2 and 3. So we have to give closed intervals at 1, 2 and 3. Now if you don't know the difference between open and closed interval, I will just clear it for you. When we write something like AB, x belongs to AB, it means x belongs in the interval between A and B, but it never attains the values of A or B. But when we write x belongs to closed interval AB, it means it belongs in the interval a to b, and it can also attain the value of a or b, which means this means inclusive, this means exclusive. Okay, so now fx greater than equals to 0, this implies x belongs to minus infinity to minus 3. This will be open. Union minus 2 to minus 1, again open. Union, now closed interval 1 to 2. Union 3 to infinity. Now we never give closed interval at infinity or minus infinity. We always give open interval there. So this is the answer of fx greater than equals to 0. Okay. So now the question is solve for x minus 2 whole cube into x minus 1 whole square lesser than 0. So let's solve this. So now let's do as we did in the previous problem. We have drawn a number line and plotted the 2 points 1 and 2. No denominator here, so both the points are given black circles. No points of discontinuity 1 and 2 here. So now in the last sum, all the factors of the numerator as well as the denominator had their powers as 1, but here one has its power as 3, another has its power as 2. So what to do here? Now remember, whenever any factor, whether it's of the numerator or the denominator, it has a power which is odd, like 1, 3, 5, 7, 9, then sign will change at that point. Meaning if the curve is upwards on its one side, then it will be downwards on its other side. And if it's an even number 2, 4, 6, 8, then no sign change. So let's see here, 2 odd number, sign change will take place. 1 x minus 1 even power, so no sign change. So let's start from here. It starts from here, crosses, sign change takes place, goes here, but no sign change will take place here. It will go downwards. So plus, curve is below, minus, curve is below again minus. So this is the difference. No sign change takes place here at 1 because x minus 1 power is even. So now lesser than 0, we will have to see where it's minus, these two places. So x belongs to, many will write minus infinity to 2, but no, that's totally wrong. Because if you write minus infinity to 2, that means you are also including this 1. But if you put 1 in the function, it will give you 0. But it's not given lesser than equals to 0. It's given lesser than 0. So you can't include 1 which is a 0 of the function. You have to exclude it. Now how can you exclude it? There are two ways of writing it. Whichever you find convenient, you can use it. First way is you break it into two parts. X belongs to minus infinity to 1, open interval, union 1 to 2. So that means 1 is not included, both sides open interval. This is one way. Another way is you can write this one, x belongs to minus infinity to 2, and then exclude only 1 from that interval. Now this is the way of writing discrete elements. Okay. So after solving the two problems, we can generalize the Wavy Curve method into these 5 points. Plot the zeros of both the numerator as well as denominator on a number line. Mark the zeros of the numerator with black circles and the zeros of the denominator with white circles. Mark plus in the rightmost interval and gradually come left. If x minus I has an odd power, change sign at ai, and if even, don't change sign. After drawing wavy curve, if inequality is lesser than 0, take intervals with minus sign, and if inequality is greater than 0, take intervals with plus sign. If it is lesser than equal to 0 or greater than equal to 0, ignore the is equal to and take the intervals first. Then give closed intervals at the zeros of the numerator. And how will you find the zeros of the numerator? The points which are marked with black circles. So now we will solve a few more problems of Wavy Curve method. So let's take this problem. 1 by x is greater than x by x plus 1. Now in these type of problems where there are functions on both sides, first we have to express it in the form of wavy curve problem, and only then we can apply the wavy curve method. So how to express it in that form? Now what many people will do is this, they will cross multiply this and write x plus 1 is greater than x square, but that is totally wrong. Why I am telling you? Suppose I am writing 2 is lesser than 3. Now if we multiply minus 1 to both sides, we have to write minus, we will get minus 2 minus 3, but now it's no more lesser than, minus 2 is greater than minus 3. So multiplying with a negative number changes the sign of the inequality. Now here, when we are cross multiplying, what we are doing? First we are multiplying both sides with x, then we are multiplying both sides with x plus 1. And we are still not changing the sign. So that means we are taking x and x plus 1 to be greater than 0. Or if we change the sign, then we are taking both of them to be negative. But we don't know if they are negative or if they are positive. So how can we multiply? We can't multiply. So how to express it in the form of a wavy curve problem? Just subtract it. 1 by x minus x by x plus 1 is greater than 0. X into x plus 1, and here it will be x plus 1 minus x square is greater than 0. So now multiply it by minus 1 on both sides, so the inequality sign will change. X square minus x minus 1 by x into x plus 1 is lesser than 0. Now x square minus x minus 1, this will not give integral roots, but this gives irrational roots. But let's find it. X square minus x minus 1, so the roots are 1 plus minus root over 5 by 2. So we can write this as x minus 1 plus root 5 by 2 into x minus 1 minus root 5 by 2. Okay, so let's write these two here. X minus 1 plus root 5 by 2, x in minus 1 minus root 5 by 2 by x into x plus 1 lesser than 0. So now this has come in the form of a wavy curve problem. Now we can apply wavy curve on this problem. Yeah, these two roots have come out to be a bit weird because of the question. Sorry, it was x here, but else it has come out to be a wavy curve problem. These two are real numbers after all. And now let's apply wavy curve. So we have calculated the values of 1 minus root 5 by 2, 1 plus root 5 by 2, and we have plotted them accordingly on the number line. So now, since all the powers here are 1, so no problem, just keep on changing signs, plus minus plus minus plus, and we have drawn the wavy curve. This is rejected, this part. Okay, this will go on because this is till infinity, till minus infinity now. So this was lesser than 0. So now let's find the intervals. X belongs to, we have to find the minus intervals. Minus 1 to 1 minus root 5 by 2, union 0 to 1 plus root 5 by 2. And this is the answer of the problem. Okay. Yes, in this problem I forgot to plot the points with those black circles and white circles, but I hope everyone can get it now. 0 and minus 1, these two will be white circles, the other two will be black circles. Okay, but since it's only a greater than problem, no is equal to, so this will not hamper. So now another type of problem, but here two different things have come up. First, the exponential function e to the power x, and then the logarithmic function ln x. Now I will imagine this is not a Wavy curve type problem. So how can we solve this using Wavy curve? Just express it in the form of a Wavy curve problem. Now how to do that? See, e to the power x minus 1. We have to find where does this become 0. This becomes 0 only when e to the power x becomes 1, which is possible only when x becomes 0. So 0 is a 0 of this function e to the power x minus 1. Okay, so we can, for the sake of expressing it in the form of a Wavy curve problem, we can write e to the power x minus 1 as x square into x minus 2. And similarly, the logarithmic function, if you know log, you will surely know it that ln x becomes 0 only when x is equals to 1. Okay, so we can express it as x minus 1 greater than equals to 0. And now it is in the form of a Wavy curve problem. So draw a number line, plot it 0, 1, 2, and mark 0 and 2, mark it with black circles, 1 with white. Here you will write it, start from plus. See, even power is only on x, so at 0 no sign change, all other points sign change, plus minus plus, and here also plus. Without even drawing the Wavy curve, you can solve the problem after a few times. As you can see here, it will not go downwards, it will continue here only. So the intervals, you will take it greater than equals to 0, so we have to take the positive intervals. That means positive is here, here, and here. So x belongs to equals to 0, so you can include 0 and 2. X belongs to minus infinity to 1, open interval, union, this will be closed interval, union, 2 to infinity. So both 0 and 2 are included. X belongs to open interval minus infinity 1, open interval, union, closed interval 2, and infinity we as usual give open interval. So this is the answer. So I hope this topic is now clear to everyone. Still, if you have any doubts, feel free to ask me in the comment section, and all feedbacks to this video are very much welcome. Please like my video and share it with your friends as much as possible, and please subscribe my channel, and don't forget to press the bell icon for further notifications. Thanks. We'll soon meet you in the next video. Bye bye.